This example is from section 2.4, day 1. This is our second example here. We just had talked about long division, but the good news is you don't have to use long division every time. We can use synthetic division in most of the cases that we come up with in this chapter and with polynomials in general. Long division is most of the time not necessary. Synthetic division can be used when the divisor is in the form of x minus k or any other linear divisor. It just needs to be linear in order for this whole thing to work. So the divisor in this problem, as you'll see, is 4 minus x. Now it's okay that it's not x minus k in that form. It's flipped around because essentially what you're looking to do is whatever makes this equal to 0, that's going to be what we have as our k value. So k in this case is equal to 4. So that's what we're going to use out the side of this bar with our divisor, and then we're going to do a specific algorithm to get through and divide 4 minus x from this 5x to the fourth polynomial. So next thing that we do is we're going to put the coefficients from the dividend inside the box. We start with the highest power, and that's a 5. Now notice it's 5x to the fourth. There isn't an x to the third, or an x to the x squared for that matter. So we do have to do a couple placeholders in there. So for x to the third, there's 0. For x squared, there's 0. And then finally we're down to our x, which is -3. And then our constant term, which is 1. So you do need to fill in all of those zeros and placeholders there, because otherwise you'll get something that's a much different degree than what the answer should be. So once we do that, we're going to start the algorithm, and that is, to begin with, we bring the 5 down and write it down here. That's all you do to start. Once you have that number down here, we're going to multiply it by the k value, and so 4 times 5 is 20. And now that we have this, we're going to take these and add them together. So that'll be 20. And then we basically are just repeating the process the rest of the way through. 4 times 20 is 80. Add those together. 4 times 80 is 320. Okay, so we're getting a little out of hand on this one. It is going to be some large numbers here. That does happen sometimes. And then 4 times 317 is 1268. I didn't quite give myself enough room here, but we're going to add the 1 and the 1268 to make it 1269. And you'll notice I did this little dotted line here. That was just to indicate what my remainder is going to be. So this is my remainder. It's always the last number that appears in your table. And so that remainder over the divisor is where we're going to start. So I kind of like to work backwards and say, all right, this means that my remainder is 1269. Divide that by the divisor, which was 4 minus x. Then I work my way backwards. Looks like the next number was 317. That is the constant term. That's just the plain number. Then it goes x squared, x to the third. And so here we've got 80x. Working our way backwards, 20x squared, and then the leading term is 5x cubed. So when you divide 5x to the fourth minus 3x plus 1 by 4 minus x, you get this thing. It's important to note that you don't ever want to just leave your answer like this. This is merely an algorithm to get the correct answer. This is the answer that you want. This is the divided product. It's the quotient, I should say. That's the right word I was looking for. That is the quotient of this problem.